Now we'll talk about gluconeogenesis, where there is a production of one molecule of glucose from any other non-carbohydrate precursor, mainly two molecule of pyruvate. In the first step, two molecule of pyruvate from cytoplasm enter mitochondria, where it will be converted into oxaloacetate in the presence of enzyme known as pyruvate carboxylase. Later, in the mitochondria, this oxaloacetate is converted into malate in the presence of enzyme known as malate dehydrogenase. In the next step, malate exit mitochondria and enter cytoplasm, where it will be converted into oxaloacetate in the presence of enzyme known as malate dehydrogenase. Later, oxaloacetate is converted into phosphoenol pyruvate in the presence of enzyme known as phosphoenol pyruvate carboxykinase. In the next step, this phosphoenol pyruvate gives rise to 2-phosphoglycerate in the presence of enzyme known as enolase. Later, 2-phosphoglycerate is converted into 3-phosphoglycerate in the presence of enzyme known as phosphoglycerate mutase. In the next step, this 3-phosphoglycerate is converted into 1,3-bisphosphoglycerate in the presence of enzyme known as phosphoglycerate kinase. Later, 1,3-bisphosphoglycerate is converted into glyceraldehyde 3-phosphate in the presence of enzyme known as glyceraldehyde phosphate dehydrogenase. In the next step, glyceraldehyde 3-phosphate is converted into fructose 1,6-bisphosphate in the presence of enzyme known as aldolases. Later, fructose 1,6-bisphosphate is converted into fructose 6-phosphate in the presence of enzyme known as fructose 1,6-bisphosphatase. Later, fructose 6-phosphate is converted into glucose 6-phosphate in the presence of enzyme known as phosphohexose isomerase. In the last step, glucose 6-phosphate is converted into glucose in the presence of enzyme known as glucose 6-phosphatase. So that is how two molecule of pyruvate gives rise to one molecule of glucose in gluconeogenesis.